Okay, problem number 14. It gives us a whole slew of things to find a derivative of. And this is going to be excellent practice, and we're going to use these ideas for the rest of the semester. So it's good to make sure that we know them. Let's go ahead and get started. So first view our routine. So a, 3x squared plus 2x minus 1 plus 2x minus 1. If we take a derivative by the power rule, we get 2 times 3 is 6x plus 2. Perfect. B, we have x cubed plus 2x squared minus x over root x. And this would be better to write, or the easiest way in my opinion to do this problem. But you actually have 3 different ways available to you if you remember the homework. Is to rewrite that 1 over square root of x, I don't know why I wrote to the 1/3, as an x to the minus 1/2. Now I go ahead and distribute. I'm not taking a derivative yet, I'm just making this function nicer to look at. Or not nicer to look at, but easier to take a derivative of. So I get x to the 5/2 plus 2x to the 3/2 minus x to the 1/2. Again, that's from the way the powers work. This would be a good algebra review if you're confused by that. That'd be a good thing to go back through and look up on. And the derivative, f prime of x, is now I bring these powers down. So 5/2, x to the 5/2 minus 1 is 3/2, plus 3/2 times 2 is 3. X to the 1/2 minus 1/2 x to the minus 1/2, and I am completely fine with you leaving your answer like that. If you want, you could write it as a new divided by square root of x, but I really don't see the point. That's completely fine as is. Excellent. C, the possibly most missed type of question. So I have sine of 9z times the square root of z. So the first thing I need to note is I'm multiplying 2 functions together. So I'm going to call f of z sine of 9z, g of z, just so these don't look like 2's, is the square root of z. F prime of z is, by the chain rule, cosine of 9z times 9. 9 cosine 9z. Right? Because the chain rule says take the derivative of sine, leave the inside alone. So I have cosine of 9z. Take the derivative of the inside. The derivative of 9z is 9, and multiply them together. G prime of z is, well, this is z to the 1/2. So this is 1/2 z to the minus 1/2. So finally, I do the product rule. So this says this is equal to first times derivative of the second. So 1/2 sine 9z times z to the minus 1/2. And then plus second times derivative of the first. And now finally, this would be fine as a final answer. Again, I won't be too particular. Yeah, let's just leave that like that actually. If you want, you can put all the root stuff together, but realistically, that's a lot of work. So we'll leave it as is. And plus, it's completely clear what you mean with that, and it makes it easier to take further derivatives. Okay, my new function, d, cosine of x squared over x squared plus 3. Now we need to use quotient rule. So my f of x, which would be my numerator, is cosine of x squared. F prime of x says use the chain rule. You get derivative of the outside minus sine x squared times the derivative of the inside is 2x. So you get minus 2x sine x squared. On the bottom, there's just regular old x squared plus 3. G prime of x is 2x. So now we have that listed. Let's call this h of x. So h prime of x is low d high minus high d low all over the bottom squared. Now I can just go ahead and plug in x squared plus 3 times minus 2x sine and I'm about to run out of room. So minus, we'll slant it like this. Cosine x squared times 2x, all divided by x squared plus 3 squared equals, and now we do have to distribute everything because we might get stuff that cancels. Minus 2x cubed sine of x squared minus 6x sine of x squared minus x squared cosine x squared, all divided by x squared plus 3 all squared. So I look through, no terms cancel on top, and the bottom is as nice as it gets. So that would be the derivative of this function. Do I have room for e? Yeah. So part e, take the derivative of sine of the square root of x squared. Square root of x squared. This is one where you have to do the chain rule twice. So my inside function is sine of root x. I'll call that u. My outside function is u squared. So if this is f of x, f prime of x is equal to the derivative of the outside function, which is 2 times, and then I said my outside, or my inside function was sine root x times the derivative of the inside function. So now I need to do this again. So my new inside function is square root of x. My outside function is sine. So there I get derivative of the outside function is cosine of x times the derivative of the inside function is 1/2 x to the minus 1/2. And now I just go through and put this up here. Times cosine x 1/2 x to the minus 1/2. Cosine root x, sorry. Yeah, so this becomes a u cosine u, but that was root x. Something looked off. Root x. So I have 2 times 1/2. Let me pick different colors. I have 2 times 1/2, so those cancel. Everything here is being multiplied together. So I get sine of the square root of x times cosine root x times x to the minus 1/2. And again, that would be fine. Just to make it more aesthetically pleasing, I'm going to write it like this. Over root x. And that's your final answer. Yes. Just double checking in my head that that's what I was supposed to get. All right, I think that's the halfway point. This one's a fun one. Square root sine of 3 to the 100th. Okay, so you might be thinking, well, we didn't learn how to take derivatives of exponentials. There's a 3 to a 100 right there. So whatever this number inside of this square root is, and actually this whole thing, 3 to 100 is just some number. Sine of that is just some number. Square root of that is some number. So trickily, this is just a constant. So therefore, if I take a derivative, f prime of x is just 0. Sure, it's a weird number. It's not one we've probably ever seen, but it's still just a number. So take a derivative, get 0. It's there to trick you, to make you think you might have to do more work. Not bad for the first one after the halfway mark. So x squared tan of x. Again, what do I want to hammer home? We absolutely need the product rule here. So we have first times the derivative of the second. Derivative of tangent is secant squared of x plus derivative of the first times the second, 2 of x tan x. And again, that's completely fine to leave like that. But let's say I was looking for zeros. It would behoove me to factor out. So either of these answers are perfectly acceptable for the exam. But just note, if you were finding zeros, you would want the bottom one. Okay. So I think I accidentally stacked these problems, so they went from harder to easier, which is fine. So sine of x to the 4th. So this is just a normal run-of-the-mill chain rule. My inside function is x to the 4th. My outside function is sine of u. So f prime of x by the chain rule is derivative of the outside. So that's cosine of u times derivative of the inside is 4x cubed. So I get 4x cubed cosine of x to the fourth, replacing u with x to the fourth. And that's our final answer there. So I've got two more left. Let me go to the next page because I can't fit both of them anyway. My hands are kind of sweaty at this point. And I was on I. Okay. So your new function is 5x squared plus 3x plus 2 to the 100th power. Now we need to take a derivative. So this is another chain rule problem. My inside function is 5x squared plus 3x plus 2 equals u. My outside function is u to the 100th. Again, this is technically possible using nothing but power rule if you wanted to expand that out, but you would get such an unreasonable number of terms that you'd be very, very sad. So instead, we will use the chain rule. So f prime of x is, we move down the 100, we get 100 u to the 99 times the derivative of the inside, which is 10x plus 3 equals 100 5x squared plus 3x plus 2 to the 99 times 10x plus 3. And that's our final answer there. Finally, we are at the almost there mark. So our function is x sine of x over x to the 1/3. So what we want to do here is kind of the same thing we did for b. Is if we can ever simplify, or if I can ever simplify and not do quotient rule, I go ahead and do that. So this is x sine of x times x to the minus 1/3. Or I get x to the 2/3 by adding exponents, sine of x. So if I kept it as quotient rule, I would have had to done a product rule, a quotient rule with a 1/3, and it just wouldn't have been a good time. Here, it's still not the best thing ever, but it's not nearly as bad as it could be. So I get, taking a derivative, first x to the 2/3 times the derivative of the second, which is cosine of x, plus derivative of the first, 2/3, x to the minus 1/3, sine of x. And again, it would be fine to leave it like this, but later on we're going to search for zeros, so I think it would be good practice to do that now. So I can factor out an x to the minus 1/3, and now this x to the 2/3 becomes x. And again, you can check that that's true by distributing back through. But that's a real handy trick we're going to use in the future, so I want to show it off now, so maybe you have some experience with it. Plus 2/3 sine of x. And that gives us our final derivative. We finished the entire problem.